Welcome. This is Coach Dorf. Let's look at a homework example from section 1.3. So in this example, we're going to look at combining functions together. So here's the problem. Let f of x equal 1 over the quantity x minus 1 and g of x equal 1 over x plus 1. And you're supposed to find what is the sum of these two functions, the difference of these two functions, the product of these two functions, and the quotient of these two functions, and state their domains. So let's first look at what are the domains of f and g by themselves. So f of x is 1 over x minus 1. Now, remembering from the lecture, we talked about that there are three types of conditions that you need to look for in order to determine if there are restrictions on the domains. Those three are if it's a rational function, i.e. it looks like a fraction, and you can't have 0 in the denominator. If you have a square root in the function, then what's inside the square root has to be positive or equal to 0. And the third one is log functions. The log function, the term after the log function, has to be greater than 0. Now, in this case, for f of x, it looks like a fraction, a rational expression. So the denominator can't equal 0, all right? So what do we have here? This x minus 1 cannot equal 0, which means x cannot equal 1. So the domain of f is negative infinity to 1 union 1 to infinity. Oops, that doesn't look very good. Let's try that again, to infinity. All right, for our second function, g of x, it is 1 over x plus 1, all right? We have also a fraction involved there. Oops. Here, so x cannot equal 0, and so that means my domain of g is going to be negative infinity to 0 union 0 to infinity. Now, don't be confused with the plus 1 that comes after the 1 over x and g, all right? There's no problem with a plus 1 there. But maybe if you're still not sure about that, let me rewrite g. So g of x is 1 over x plus 1. Well, let's get this so it's just one fraction or one rational expression. So in order to combine these two things, we have to get a common denominator. Now, the first part, 1 over x, has a denominator of x. 1 doesn't have a denominator, but it does if you rewrite it as 1 over 1. All right, now, what's the common denominator? Well, I have an x and I have a 1, so I can multiply those two together to get a common denominator, and that would be 1 times x, which is x. All right, so I have 1 over x here because that doesn't change, but now I need to take 1 over x, multiply it by x to get that in the denominator. And if I do that, I have to multiply the top by the same amount, x. All right, so that's the same thing as 1 over x plus x over x. And you can see that on the right-hand side there, x over x is the same thing as 1, so it's equal to what we started with. Now that I have a common denominator, I combine what's on the top together to get 1 plus x over x. And some people may prefer to write this as x plus 1 over x. Either one is correct. Now, if I look at that function, what is the domain of it? Does it change at all? Well, the domain of g, if I look at that function, I've got that rational expression, and still I've got that x in the denominator, and so x not equal 0. That's the only restriction. So the domain is still negative infinity to 0, union 0 to infinity. So now let's start tackling this problem. Part A says find f plus g. All right, so I'm going to take my f of x plus g of x. So that's going to equal 1 over x minus 1 plus 1 over x plus 1. Now, in order to add these together, I need to have a common denominator. So I'm going to substitute in the work that we just did for this g of x. We know that that is equal to x plus 1 over x because of what we did up here. All right, so I'm going to have x plus 1 over x here. Now, I'm going to add these two fractions together. To add them together, I want to get a common denominator. So what's my common denominator? Well, it's going to be x times x minus 1. I'm going to multiply the two denominators together. So first I have x minus 1 over x minus 1. And so I want to multiply an x on the bottom. So I have to multiply the top by an x to keep it equal. And for the second fraction, I've got x plus 1 over x. I want to multiply the bottom by an x minus 1. So I multiply the top by an x minus 1 so that it's equal. What I'm multiplying on the right side of those things, both here and here, these equal 1. And so it's legitimate for me to multiply those because I can multiply a math expression by 1 and it doesn't change anything. All right, so now when I do that, I multiply everything on the top together. So 1 times x gives me x. And on the bottom, I'm just going to write it like this. I could multiply those together to get x squared minus x, but I'm just going to keep it like this. On the top, I've got x plus 1 times x minus 1 all over x minus 1. And now what happens, we're going to do a little aside here. What is x plus 1 times x minus 1? All right. You're going to use what's commonly called the FOIL method. I've got two terms in each parentheses, so I have to multiply parts together. I do the first together and I get an x squared, x times x. Then I do the outside ones. X times a negative 1 is a negative x. Then I do the inner ones. 1 plus 1 times x is plus x. And then I do the last ones. Plus 1 times minus 1 is a negative 1. And then I see that the middle terms cancel out. And so then I get x squared minus 1 as my final answer for that. So in the problem we were working on, we're going to have x over x times x minus 1 plus x squared minus 1 all over x times x minus 1. Now that I have a common denominator, I can just go add the numerators together. And so I have x plus x squared minus 1 over x times x minus 1. And it's common to write the term with the highest exponent first. So if you were to check the back of your book, which is perfectly fine to do, as long as you do the problem first, don't check the answer before you do the problem and then check your answer. But they would probably write it like this: x squared minus x plus x minus 1 over x times parentheses x minus 1. Now, some of you, again, may have thought, well, let's multiply the denominators together to get x squared minus x, which is correct. But the reason I like to keep it like this way is because you're supposed to figure out what is its domain. Well, it's easier to figure out its domain by keeping it in this form, because this is what's the restriction on the domain. Remember the three types. This is a rational expression like a fraction, so I can't have my denominator equal to 0. It's much easier to evaluate the case when this would equal 0 by keeping it as x times x minus 1 instead of multiplying those together to get x squared minus x. All right. So when can the denominator equal 0? Well, it would equal 0 if x is 0 or x minus 1 equals 0, which would be x equals 1. So the domain, we have x cannot equal 0 or 1. And so the domain of plus g is negative infinity to 0, union 0 to 1, union 1 to infinity. Now notice that when we started off here, my domain of g was this, and my domain of f was this. All right, f was missing, couldn't be 1, g couldn't be 0. And in this particular case, the domain of f plus g is the same, is a combination of those two, where we can't have 0 and 1. That was part A. Let's go to part B now. What if I subtract these together? So if I do f minus g, so we know that this is going to be from what we have earlier. We're going to have 1 over x minus 1. And now I'm going to write the simplified form of g, which was the x plus 1 over x. All right. Again, I need to get a common denominator. We did that in the previous problem, so we're just going to copy what we had from the previous problem, and that was, it was x over x times x minus 1 minus x squared minus 1 over x times x minus 1. Where did that come from again? This was the same thing that we did up here, and now the only difference is instead of having a plus between them, we have a minus. So we don't have to redo the work every time if we've done it correctly here. Now, I'm going to subtract these. So what do? I'm going to have x minus parentheses x minus 1 over x times x minus 1. Now remember, I had said earlier in my video for this section that this is a common mistake. Common mistake is not putting that parentheses here. That parentheses needs to be there, needs this parentheses. And why is that? Because if you don't have that parentheses there, you're going to have x minus x squared minus 1. And that's not going to be right. So you need, common mistake is to forget to include parentheses. And then the second common mistake is even when you have the parentheses, here. What is x times parentheses x squared minus 1? Well, you have to, so what some people would do is this, and that's not right, not correct. That doesn't equal that. What is correct? If I do x minus x squared minus 1, I need to distribute this negative to both terms to get x minus x squared. And then I have a minus negative 1. So that's going to be plus 1. So this is correct. So going back to my problem, my little side tangent there, that's a math joke. Hopefully you appreciate the math jokes. Getting away from my tangent, we now have x minus x squared plus 1 over x times x minus 1. And as I mentioned earlier, they often put the term with the highest power out front. So you might see the answer as negative x squared plus x plus 1 over x times x minus 1. And what's the domain for this? Domain of f minus g. Well, again, we can't have 0 in the denominator, which means x cannot equal 0 or 1. And so the domain is going to be negative infinity to 0, union 0 to 1, union 1 to infinity. And again, this is just like what we had for f plus g, which was the same as the combination of f with g, those two domains. Let's go to part C. Part C is what is f times g? So f again is f of x times g of x is going to give me 1 over x minus 1 times, and I'm going to use my new expression for g, which was 1 plus x over x. I'm going to multiply those together. Question, do I need to get a common denominator? No, I don't. I get a common denominator if I'm adding or subtracting them, but if I'm multiplying, I don't need to do that. I multiply the tops together and multiply the bottoms together. So when I do that, when I multiply the tops together, I get 1 times 1 plus x, and that gives me 1 plus x. On the denominator, when I multiply those together, I get x times x minus 1. It doesn't matter if the x comes first in the denominator or the x minus 1. I just put it that way. There's your answer. And what's the domain? Well, again, what do we have here? We have a rational expression. I can't have 0 in the denominator, so we can't have x can't equal 0 or 1. And so our domain of f times g is going to be negative infinity to 0, union 0 to 1, and union 1 to infinity. All right, last one to consider is what is f divided by g? So I have f of x over g of x, which can be written as f of x divided by g of x. All right, so f of x was 1 over x minus 1 divided by 1 plus x over x. Now, how do I divide fractions? Do I need to get a common denominator? No, you only get a common denominator if you're adding or subtracting. So I don't need to do that. But I've got a division here. What do I do division? Well, division of fractions is the same thing as multiplying by the reciprocal of the second term. So I'm going to take the reciprocal spelled this way, reciprocal. The reciprocal means I will invert what I have for the second fraction, which means I'll put what's in the denominator in the top, and what's in the numerator, I'll put in the denominator, and I get this. So that's equivalent to that. Now, we could go into an explanation why that is, but that's not my purpose right here. All right, I just wanted to review that with you. So I'm going to multiply these two together now. When I do that, I multiply, just like we did in the previous part C, multiply the tops together, and we multiply the bottoms together. And if I wanted to, I can rewrite this as x over x minus 1, and then switch the second term to be x plus 1 instead of 1 plus x. It's exactly the same. That's my answer. And now what's the domain? Domain of f divided by g. Well, this is the tricky part here, okay? So I'm going to write this tricky here. Be careful. If you look at the final answer, you're going to say the domain that you can't have a denominator can't equal 0. All right, and when would the denominator equal 0? So that would mean that x can't equal 1 and x can't equal negative 1. So you would say perhaps the domain f over g is negative infinity to negative 1 union negative 1 to 1 union 1 to infinity. But let me get a good color here. This is not correct. Why is it not correct? Well, when we divide the fractions here, when we divide the functions, over G, we have to take into account what is possible for F and G in the first case. So we have to recall, domain of G does not contain 0. In other words, the domain of G was -infinity to 0, union 0 to infinity. So since we're dividing these fractions, I have to start off with the fact that 0 can't be in the domain. And I include that into my final result here. So for the domain of F divided by G, we have x cannot equal 1, it cannot equal -1, and x cannot equal 0, because G can't have 0 in its domain, and we need that before we start off with a function. Now, some of you may say, well, what about F? We have to also include that. Well, we do, it's already there, because remember, F is 1 over x minus 1, so F doesn't contain 1, and this is then part of domain of x, of F there. So it's already included in what we have. So the final answer would be domain of F over G is, we have -infinity to -1, union -1 to 0, union 0 to 1, union 1 to infinity. It's missing those 3 points that are marked here. All right, so the difference here, just to make sure that everyone's clear on this, there's a difference. There's a difference between domain of what we had for F, which was this, x over x minus 1 times x plus 1, and domain of F over G of x equaling x over x minus 1, x plus 1. So in the first case here, if we just had the fraction x, or the rational expression x over x minus 1 times x plus 1, the domain would be -infinity to 1, union 1 to -1, union, oops, I had those backwards. -1 there, make that +1, +1 to infinity. X cannot equal -1 and 1, because this is just what we're starting with. We started with that. But on this one, we didn't start with the x over x minus 1, x plus 1. We started with this. We started with this. And so we need to include restrictions on F and G, which in other words is x cannot equal 0, because that's the restriction there. And in this case, in green here, in this case, we started with this. So we started with different things here, and that's why the domains are different. All right, hope that helps you with the homework. Have a good day.